Okay, next factor is what? Response reduction factor, which is again depending on the type of framing system. There are different values 1, 1.5. So you can select that value depending on the type of structure frame. Next is what? Importance factor. Importance factor is also one of the important factors designing in earthquake related forces. So there the importance factor मतलब क्या है, तुम्हारा स्ट्रक्चर कितना इंपॉर्टेंट है सोसाइटी के लिए या तुम्हारे इंडिविजुअल प्लेसेस के लिए वेयर यू आर स्टेइंग. तो इम्पोर्टेंस फैक्टर्स डिपेंडिंग ऑन इम्पोर्टेंस ऑफ द बिल्डिंग्स. सो उसके लिए भी अलग अलग वैल्यूज हैं टेबल में. वो भी एक टेबल है उसमें, वो टेबल तुमको रेफर करना है. उसके बाद रॉक एंड soil site factor, that is depending on the type of soil, on which type of soil you are constructing your structures. There are three type of soils available in and around the area. कौन कौन से बोलो, कौन कौन से बोलो? Low, medium and high. What is low, medium? Low type of soil where the SPC of soil is very much low. Medium type of soil is the type of soil where the SPC of the soil lies between 50 to 150 like that. Next, high strata soil having SPC of safe bearing capacity of soil more than 150 ton per meter square. It is classified. So you have to also decide the type of soil, whether type 1, type 2 or type 3. Only type 3. Here the other values you have to specify it, or you can leave it also, it will calculate automatically. So what we'll do is we will specify the same values and then we will add this. After adding, it is added in this sorry, seismic parameters generally can be defined only once in STATO model. Okay, now look at here. That property of the seismic parameters is added in this loading window. Look at here. This is added. Now click on this and click on. No, sorry, already it is defined now. Now go to load cases. Like in the morning class we have done. Huh? So individual load cases you have to define now. What are the other loads? First you have to define is the seismic loads. Go to seismic loads under this category and assume that the seismic load is taken as EQ, earthquake load, with x plus direction. With x plus direction. Add it. Another load case will add it over here only. EQ x minus. Click on add. We can add also, or we can change it. Only we will take in two directions, x and z directions. So we'll take only x and z directions. EQ x plus EQ z plus. We will take only two directions. उसके बाद क्या ऐड करना है? नेक्स्ट लोड केस इज डेड लोड. उसके बाद लाइव लोड. उसके बाद dead loads. Live loads, dead loads, and the combinations. So we will add now the other load cases. Go to new under load case. Load case number 3 is a dead load. Next load case will add live loads. Click on add. So these are the number of individual load cases we have added. Under this load cases we have to define their loads. So first one is EQX plus. Click on EQX plus. Click on add. Next we need to define some seismic forces here, seismic loads. Click on seismic loads. We have already defined some important definitions of seismic forces according to which zone, what are the seismic parameters, already we have defined. Now we have to just define here the direction, in which direction the seismic is coming on the structures. So here first the direction x with a factor 1 and then click on add. Next click EQZ, add seismic loads. Here you have to define the directions Z with factor 1. Click on add. Next under dead loads. Under dead loads, what are the loads acting under dead loads? Those also we have to define it now. Go to add first sulfate, add it. Next member loads. What are the member loads? Minus कितना है वो? Wall load intensity minus 15.3 in kilonewton per meter. Add that. Next another minus 5.1 ne? That is all. Also in kilonewton per meter. Next dead load parapet कितना है वो? Minus 1.8. Add it. So now look at all these are showing with question marks. So to define the sulfate or to assign the sulfates to all the members, select the sulfate and directly click on assign to view. Assign to view and then click on OK. Assign it. उसके बाद next one, these wall loads, where these wall loads are acting on these beams. Select these plinth beams, ground floor beams, first floor beams, where the external wall loads and internal wall loads are applied. Go to isometric view, see whether all the beams has been selected or not. After that, click on right button of your mouse, click on new view, click on OK. So all the beams which are already been selected come to the new window. Now go to plan, where all the beams are now in the same line. Okay. So now select this external wall load intensity and select all these beams, exterior beams, where the external wall loads are applied, and then you assign to selected beams. Click on assign. Do you want to proceed? Yes, it is already been added. Next, these are the wall loads which are acting on the partition wall loads, act as partition wall loads. Click on this. Again go to plan. Now select these beams which are remaining in between the floors. On these beams, partition wall loads are acting. And again assign to selected beams, assign it. Next, partition wall loads, where the partition wall loads are usually acting on. They are acting on. Go to display whole structures and select all the beams which are at top level. Go to new view. Go to again plan. Select all this top floor beams, exterior part or this periphery of the beams, and again assign to selected beams. Assign it. Look at these parapet loads added on the top floor beams. Next, go to again display whole structures. See whether all the loads has been added. Sulfate, external wall load, internal wall load, parapet wall loads. Next, under one more dead load is due to dead load of slab and flow finish of slab. So that also you have to add it under this. Go to add. Go to floor load. What is the separate dead load of slab and flow finish? Dead load added based on the depth of the slab along with the density of the RCC slab. So it is calculated as 3.75 plus how much is the flow finish we are taking? 1. So adding both you will get minus 4.75. Correct? After that, you have to define the ranges in y direction, in x direction, and in z directions. So where the slab loads are acting on, they are acting on these floors. You have to define their heights, their x, their z directions. Ranges. Minimum 1.5 or 6. Maximum height, maximum y range value 10.5 meters. Next, minimum x value 0, maximum value of x 6 meter. Minimum value of z 0, maximum value of z 8 meters. Click on add. If you click on that wall load or slab loads, those slab loads panels are on the, it is added on the panels of the slabs. Is it over? These are the number of loads acting in the dead load case. Next, live loads. Under live load, only the loads are coming due to slab live loads. So click on again floor loads. And here you have to define the intensity of the live load on the floor minus 5. Next, define the same ranges of slab in y and z x axis. 1.6 minimum y range, maximum y range 10.5 meter, 10.5 meters. Next, minimum x 0, maximum x 6 meters, minimum z 0, maximum z 8. Click on add. Click on add. So after just clicking on that, you will see the live load is added on the floor in the different load case. ये different load case है dead load, ये different load case है और ये different load case है. Okay. Now we'll see how to add the combination of these loads, because the structure is not designed for specific loading conditions, but they are designed for the combination of loads along with the factor of safety. So अभी क्या करेंगे? We will add the combination of loads, and again under the load cases details, click on new, and here you have to specify the load combinations. See here, these are the number of loads already we have assigned on the structures. Okay, so here under this we have auto load generations. You have to first define according to which code you are designing your structures. If you are designing as per Indian conditions, click on Indian code, generate. Look at it is generated. वहाँ पे generate नहीं हो रहा था, अब यहाँ पे हुआ ना. Look at how many. Earlier कितने थे तुम्हारे? सिर्फ कितने थे वहाँ पे? 5 थे ना. तो अभी कितने हुए? As per the IS code specification, when you go for auto load generations, the all load combination will be added in the structures as per the IS code specifications. Next, you click on add. Look at these many number of load combinations done. हम कितने ऐड किए थे? सिर्फ यहाँ तक ऐड किए थे, लाइव लोड तक. अब IS कोड क्या कर रहे हैं? इस पर इंडियन स्टैंडर्ड कोड जितने लोड कॉम्बिनेशंस हैं वो पूरे लोड कॉम्बिनेशंस का लिस्ट आ गया यहाँ पे. Look at here. What is first value indicating? First, after live load, what is next load combination is 1.2 times of load case number 1. What is load case number 1 is? Seismic load along x direction plus इसका 1.2 मतलब जितना भी earthquake load आ रहा है उसके साथ 20% एक्स्ट्रा ऐड हो रहा है उसमें. 1.2 मतलब. नेक्स्ट अदर लोड कॉम्बिनेशन लाइक नेक्स्ट क्या है? 1.2 इंटू लोड केस 2. लोड केस 2 इज अगेन earthquake load acting in z direction. उसका भी 20% ऐड करके लोड केस अलग हो गया. आगे क्या है? ऐसे बहुत से हैं, लास्ट में भी है देखो शायद और एक. Can you see that number of load cases added here? Okay, after that just close it. The loading part is over now. We will see the output. Before going to the output file, we have to keep some commands in the processing mode. Go to commands, analyze, perform analysis, no printout, okay. Again go to commands. If I want to see the results after analysis, that is post analysis print. Under that analysis result, add command. Next, now you analyze your structures. What is error? You may get certain errors in the output file. No node case defined for UPC for terminated. Sometimes you will get an error. Those errors you have to remove it by defining some values over here. In the definitions, I think we have not defined some values. Those values you have to define it. Uh, Go to loading conditions. In the definitions, Indian standard conditions, type of structures. Uh, Here you have to calculate some time period. There is one simple formula in the AS code given for calculating time period. Time period is the time when the structure responds during the earthquake force. That is called as time period. You might have studied in yes, dynamic में पढ़ेंगे क्या? SB में time period. Time period along both the directions you have to calculate. Simple formula is there. So AS को note करो. I think the formula is 0.09 into root of h. 2016 है ना? Small formula is available there to calculate the time period. Simple formula is available. ये बहुत lengthy part है. 0.09 into h divided by root d. See, before defining this time period in x and z direction, simple formula is that formula is 0.09 h under root of science along x axis. Time period along x axis is equal to 0.09 h divided by root of d. When h indicates the overall height of the structures. What is overall height of the structure is 10.5. And root d 0.09 into 10.5 meters divided by root d is the minimum dimension. If you are calculating along x axis, what is the minimum value of x at the base line? हमारा इसका total plan dimension, right? This is the total plan dimension, and this is along x axis and this is along y axis. If we have created a plan like this, what is the dimension of the plan at the base level or a lip level in this direction? 68, 6 meters. Let's calculate time period on this one. Similarly, if you are calculating time period in that direction, z 0.09 into s remains same 10.5 divided by here t is now in this direction 8. We are getting two time period values. Those values you have to specify in this box is provided. Period in x direction and time period in z direction. Both the time period values you have to write in seconds. Every seconds. Answers are in seconds. 0.385 in seconds. Similarly, over here 0.334. That is also measured in seconds. Both values have to specify. 0.0 कितना है वो 0.0385 no in x direction. Next in the next table, next column 0.334. Next click on change, and we will analyze it once again, see any errors are coming or not getting. Again some errors are coming. Sometimes what is happening is, in some of the limited portion of this version, these IS codes may not be supported. No loading defined for UBC loads. Run terminated. Already we have defined. Let us take factor 1. Under this definition, you can also define the factor as 1. Okay, now we will analyze it once again. Now it is getting no error. No errors, no warnings. So now the complete analysis is done within 2 seconds, within 1 or 2 seconds. Seismic analysis. Now we'll see the results of the output file. This you can close it now. We will see for different loading conditions how the structure responses in animation. Go to animation. Due to the first load case earthquake along x direction, apply it, and let us take section displacement, and let us change the scale of the displacement from 1000 to nearly 10 or 1:5. Click on apply. Look at how the structure is responding against seismic force happening along x-axis. Similarly, if you click on the other load cases, what is next load cases? What is next load? Next load case we have defined seismic load along that axis. In this direction, if when the earthquake is coming from, then this is how the structure responds. उसके बाद what is next load applied? Due to dead loads. Only this is the response of the structures against dead loads. Next, against live loads. Next, with factor of safety 1.2 with earthquake load along x-axis. That means when 20% extra load is added during earthquake force, this is how the structure is. If you go on clicking the other load cases, you will see the performance. For every load cases, you can see how the structure responses, and you will see also the displacement values, how individually the original points get displaced from their original positions to the new position during earthquake forces or during any positions of loads. तो ये तुमको देखना रहता है, ये ऑब्जर्व करना रहता है स्ट्रक्चर एनालिसिस करने के बाद. Even we can see the other dimensions, other diagrams also. This is for just animations. Now if you want to see the output files in the form of here, this is how the structure responds. What this green what this black color line shows, the original position of the structures during the earthquake or during this load case, how it responds with different directions. Go to front view. You will see this original positions get shifted from original to till green color due to earthquake forces along x directions. In z directions, you can see from the side view. Next, due to dead loads, the structure responses or the structure displays vertically. Can you see that? The vertical displacement is taking place. Next, due to live load also some displacements. Due to other combination of loads, you will see deflections. So in general, you'll see the displacement values with summary. How individually critical joint get displaced in all the directions along x, along y, and along z directions, and their resultant values. So this table is very much important. You will see how much the original joints get displaced. कितना बोलो यहाँ पे हाईएस्ट कितना है यहाँ पे is it 6.666 like that something यहाँ पे 6.266 दिख रहा है मुझे तो वो कितना है इसमें डायमेंशन व्हाट इज लुक एट द यूनिट ऑफ डिस्प्लेसमेंट only 6.66 in millimeters which is very negligible that means whatever the dimensions we have assigned those are safe dimensions. Now you can see the other diagrams also. Go to modeling mode or post-processing mode. Close this displacement diagram and see the shear force diagram. How the shear force diagram is taking place again due to all load cases. अब ये shear force diagram किसका है? Due to the earthquake load along x-axis. This is the shear force diagram due to the load cases along z-axis. That is earthquake load along z-axis. Next, dead load, live loads with a combination of loads. So for every case of loadings, you can see which is the critical load combinations. So in which case you are finding the most critical shear force diagram. इसमें ज़्यादा आ रहा है. You have to say this one. Due to the dead load applied on the structures, the shear force is maximum. And here, similarly, bending one diagram. Close this icon for shear force and make active this bending one diagram. Again, the bending one diagram can be seen for other load cases also. Earthquake load along x, along z, dead load, live loads, other combination of loads. So again, under the dead loads, the bending moment values are more. If you have to take the printout of these drawings in the examination, किसका किसका प्रिंट आउट लेना है शेयर फोर्स डायग्राम का बेंडिंग मोमेंट डायग्राम का लोडिंग डायग्राम का फिर बाद में वो डिफ्लेक्शन डायग्राम ये तो कंपल्सरी लेना है एनालिसिस पार्ट में फर्स्ट डायग्राम इज व्हाट द लोडिंग डायग्राम अब लोडिंग डायग्राम को कहाँ मिलता है यहाँ पे मिलता है देखो ये जो आइकॉन है ना ये आइकॉन ये लोडिंग के लिए क्लिक ऑन दिस हटता नहीं क्या है हाँ ये जो डायमेंशंस के लिए है इसको नहीं हटा सकते click on any of the loading case see what those arrow marks showing and now if you look at in the front views you will see the amount of seismic loads acting at the top story level it is highest compared to at the bottom level. There is a base shear going to develop during the earthquake force when earthquake is acting on the structures at the base level it is highest but as the structure height goes up from the ground level तो तुम्हारा जो seismic का जो against force रहता है नहीं वो कहाँ ज़्यादा रहता है वो top story level में look at that arrow mark intent magnitude is highest compared to at the other levels it goes on decreasing from top to till bottom level but bottom level में कौन सा फोर्स ज्यादा रहता है अब तुम्हारा सीस्मिक इधर से आ रहा है सीस्मिक फोर्स इधर से आ रहा है तो हाउ योर स्ट्रक्चर रिस्पॉन्स अपोजिट डायरेक्शन में रिस्पॉन्स करने वाला ना वो तो अपोजिट डायरेक्शन में रिस्पॉन्स करते जाएगा कहाँ से बॉटम से लेकर टॉप में तो वैसे ही तुम यू कैन सी द अदर लोड केसेस आल्सो लाइक फॉर ये कौन सा है ये z एक्सिस में ये सेकंड जो है z एक्सिस में ये क्या है डेड लोड का है ये क्या है लाइव लोड का है हेलो, वाइट में भेजूँ? भेज दो। तमिल का ही, तमिल तमिल का नंबर है क्या? सो दीज आर दी अदर टाइप ऑफ लोड्स। ये कौन सा भी एक डायग्राम को लेना है। सीस्मिक लोड्स में अर्थक्वेक लोड का एक लो, बाद में ये कॉम्बिनेशन का एक कौन सा भी ले लो। उसके बाद शेयर फोर्स डायग्राम, बेंडिंग मोमेंट डायग्राम, और अगर डिजाइन तुम अगर कर रहे हैं तो डिजाइन ऑफ फोर्स। डिजाइन का तो स्टेप सेम है, लास्ट कल बोला था ना। अगर और किसी को कुछ डाउट है डिजाइन के बारे में तो कल पूछो मुझे मॉर्निंग, ठीक है। अभी वो एनालिसिस पार्ट कंप्लीट कर लो। एनालिसिस कंप्लीट करके डिजाइन पार्ट अगर मैं चाहिए तो और थोड़ा मैं कल बोलता हूँ मॉर्निंग। टुमारो विल टेल यू अबाउट सम डिजाइन पार्ट, हाउ टू कंप्लीट द डिजाइन ऑफ द स्ट्रक्चर्स अगेंस्ट seismic forces। क्या बोले? डिजाइन अभी बोलो, नहीं वो थोड़ा मुझे डिजाइनिंग के लिए नहीं, इट विल टेक टाइम। टुमारो इफ यू कम फॉर हाफ एन आवर आई विल टेक इट। तुम जल्दी आना मॉर्निंग, अगर इफ यू कम अर्ली